Hey everyone, this is question number 72 from chapter 6. I'm a fan of this question because it's about Spider-Man. All right, so the question is, what's if Spider-Man's webs are like a spring, what's the effective spring constant given these circumstances? All right, so train moving at 60 kilometers an hour, the web stretches 500 meters, and we're given the mass of the train. So the first thing we need to do is find the work that the web does, and we know that work is equal to change in kinetic energy, and kinetic energy equals so it's going to be final minus initial, and the final velocity is 0, but I will go ahead and write that out. 2v squared minus 1/2 mv1 squared. If it's bringing it to rest, the final velocity is 0. So that means the work done is going to be negative, which makes sense because this web is pulling back in the opposite direction of motion. All right, so we have gotten work equals minus 1/2 mv1 squared. And we can plug all of our numbers in for that. 1/2 10 to the 4th kilograms, and velocity is 60 kilometers an hour, which we can convert to meters per second. Let's see, 3.6. Squared, and you're going to get a value of minus 1.39 times 10 to the 6th joules. So that's the work done by the web, but we're asked for the spring constant, and we know that work of a spring equals 1/2 kx squared, and we are given x here, and we need k, and we have a value for work, so we can go ahead and solve this. Again, work of the spring is going to be negative because it's in the opposite direction of motion. 1/2 kx squared equals minus 1.39 times 10 to the 6th joules. Rearrange this, you get, and solve for x, we get k equals 2 times 1.39 times 10 to the 6th joules over 500 meters squared. And that will give us a value of 11.1 Newton meters, it's a spring constant, which will round with sig figs to 10 Newton meters.